Okay, in the seventh and final problem for now in this set, we have a metal wire of length 8 centimeters heated at one end. And the table above gives selected values of temperature, T of x in degrees Celsius, of the wire x centimeters from the heated end. And the function t is decreasing and is twice differentiable. So, as you may gather, you have this wire, and you're going to apply heat to one end, and that heat is going to be distributed through the wire or conducted through the wire, but the closer you are to the heat source, the hotter it's going to be. The further you are removed from the heat source, the cooler it will be. And so you can say that there is a derivative there. There is a rate of change of temperature per centimeter in degrees Celsius. Well, the first thing we're trying to do is to estimate T prime of 7. And the way we're going to do this is just like all the other ones. We're going to pick a point to the left, a point to the right. We don't have 7, but we do have 6 and 8. So we say T prime of 7 is roughly equal to 55 minus 62 over 2, which is negative 7 halves, or negative 3.5 degrees Celsius per centimeter. And what that means is at the 7th centimeter away from the heat source, the temperature is falling at negative 3.5, or falling 3.5 degrees Celsius for every centimeter. Second, we want to write an integral expression in terms of T of x for the average temperature of the wire. And then we're going to estimate that average temperature using a trapezoidal sum with the four subintervals indicated by the data in the table indicate units of. So the average temperature of the wire is the integral divided by the interval, and so we have 1/8 times the integral from 0 to 8 of T of x dx. Okay, so we have intervals from 0 to 1, from 1 to 5, from 6 to 8. In this case, the width of each subinterval will not be the same, so we can't factor out the h over 2 part. So in the first, we have a height of 1, and so that'll be 1/2. Obviously, we're still going to multiply by 1/8 on the outside. So we have h over 2 times the sum of the bases, or 1/2 times 100 plus 93. In the second subinterval, h is 4, so 4 over 2 is 2. So plus 2 times 93 plus 70. Then we have a height of 1, so that'll be 1/2. H over 2 is 1/2. 70 plus 62. Then in the next one, h is 2. 2 over 2 is 1. So we just want to add 62 and 55. So I call up the graphing calculator. I have 1/8, which is 0.125, times 0.5 times 100 plus 93 plus 2 times 93 plus 70 plus 1/2. 0.5 times 70 plus 62 plus 62 plus 55, close parentheses, and we get 98.563. Sorry, I had made a mistake. I missed one of my parentheses there, around the 93 plus 70. And so the final result comes out to be 75.688. And the units there will be in degrees Celsius. So we end up with an average temperature along the wire of 75.688 degrees Celsius. Once again, looking at the values for temperature in the table, you can see that 75.688 is a very reasonable amount. So we'll close down the graphing calculator, go on to part C. Find the integral from 0 to 8 of T prime of x dx and indicate units of measure. Well, by the first part of the fundamental theorem of calculus, the integral from 0 to 8 of T prime of x is the antiderivative evaluated at the upper minus the antiderivative evaluated at the lower. And so that's just T of 8 minus T of 0, which is 55 minus 100, and that's negative 45 degrees. And that is the change in temperature across the wire. And we'll continue with part D in the next video.